do is we'll start with 8.1, make sure you're good there, and which is covering the distribution of the sample mean. Then we'll move on, we'll do 8.2 is the distribution of the sample proportion. This question I made up, but it's just like the problem in your practice problems. It's just like problem number 19 on page 410 from 8.1. So I just want to let you know that. So if you practice the problem that I listed, you'll see a problem just like this. It's dealing with the gestation period, everyone, which is already normally distributed. So it is a normal distribution. So as a normal distribution, so we do know it's bell-shaped as we worked before. And we're looking at this question: what's the probability that a randomly selected pregnancy lasts more than 275 days? Now, the key word is actually this letter A right here. Let's see this A. So this is indicating this is something actually from section 7.1, where we don't have to use this. I mean, you could use this, but everyone put A, sample size would be 1, right? Mm-hmm. And so what we'll do is, let's start out with our steps. First thing is, we always make a picture, right? All right, let's make a picture. We'll make a bell curve. What's in the middle?
The mean.
266, there's the mean in the middle. The 275 is off to the right. All right. They said more than. So I'm going to shade to the right, true? All right, so there's a nice picture. We make a picture because it helps us determine how we're going to set up the problem and solve it. All right, here's the picture. We're looking at this. Step 2, we always calculated z, right? Mm-hmm. But we've done that enough times already. Where, is everyone okay if we go to the quicker function where we just use the x bars? Yeah? Mm-hmm. So when it calculates this probability, you know, previously we calculated z, we figured out what it was, but we're going to skip this step and just use the technology to solve this. And we're going to use this normal CDF function. So now when I do this, I've got 4 entries here. And when I'm not going to put z values, right, just make it go a little quicker. But I'm going to use all the x values. So in this case, because they're x's, and this was just a, I'm going to use my lower x. Here I got to put my higher x. Then I got to put the mean of whatever x was. Then I have to put the standard deviation of what x was. Cool. So what's the low x?
275.
And we're looking at that shaded region. That's why we made a picture. Because there's numbers all over the place. We're like right there, that 275. What's the high x?
1E99.
1E99. The mean of x was 266, and the standard deviation was just what? And let me know what you get. Ooh, 0.286. Awesome. Anybody else get that?
Could you use like 29%?
Yeah, you could say 29%. Because when we never round it, but this is the final answer. If you want, you could round that last answer, just make it 29%. Hey, cool. So this problem is really a question. I know I'm talking about section 8.1 here. But this is really from 7.2, where they just talked about, you know, A, randomly selected, just one. But now we get to letter B. It's like, all right, suppose you have, let's say, a random sample of 20 pregnancies. Suppose a random sample of 20 pregnancies. Is obtained. Okay. So now we've got a sample size of 20, n equals 20, true? I'm gonna ask a very similar question, but it's gonna deal with the mean of the 20, the average of all 20. So we're getting into something here. We're talking about the distribution of the sample means. So all we're gonna have to do when we enter this in our calculator, there will be one important change. Otto and I were talking about this. When we type it out like this, we're gonna be very careful in this standard deviation. Because the standard deviation here for the distribution sample mean is standard deviation divided by the square root of it. So now, suppose a random sample of 20 pregnancies is obtained. Here's the question. All right, what is the probability that look at that word mean? The mean gestation period of all of those 20 pregnancies is greater than, here I wrote more than, so I'll say more than again, is more than 275 days. Question. And we're going to do something very similar. Our picture's going to look just like this. We're going to type something very similar, but we're going to be very careful in that last entry. Because we're going to have to include this 20 somehow, right? So in this letter B, you want to see the difference in these questions? This question is, what's the probability that X was greater than or equal to a 275? This question is, what's the probability that X bar is greater than or equal to 275? So if you can, write that down. This is the difference between these questions. You know, this is just dealing with that 1X, that 1A. Now we're talking about the mean of 20 of these. Hey, last class we talked about this. We said, oh, the sample size has to be greater than or equal to 30, right? Mm-hmm. Well, that's if we have no knowledge of the distribution, or if it's skewed, but we're already told that this is a what? Normal distribution, so the sample size doesn't matter here. We're allowed to use this. It could have been a sample size of 7.
So that X is for the population and that is for the sample.
That's right.
Okay.
Very good. Very good. That's for the sample. So now I'm going to go ahead, and my picture's going to look the same, isn't it? I do want to point out it's probably going to be a lower probability logically. Do you agree? Oh, don't you think the odds will go down to get 20 women to have an average that high? Because when, you know, law of large numbers, you get more and more people together, right? Everything tends to be towards the mean. And now I'm trying to group 20 of these. I'm like, what's the odds that all 20 of them have an average that high? You're like, it's probably going to be a lower chance. So we'll see what we get. It's probably going to be lower than this. I haven't done this yet, but we'll see what we get. All right. So now, that's step 1. And when we'll bypass step 2, getting a Z, so I'll just cross that out. I write it because some students like to calculate the Z-score associated with that. So I'm just going to skip that, but I'm going to go right to step 3. And we're going to find this probability. This is 275 for X bar. And my probability will equal normal CDF. I'm going to use the calculator. The normal cumulative distribution function. That. Now remember I did low X, high X, mean X, standard deviation X? I'm now going to do low X bar. What's my high X bar? What's the mean of X bar? And then, the all-important, what's the standard deviation of X bar? So I'm going to leave myself enough room here. Because that's where I'm going to have to type this. That right there, let me just circle it. Put a star. Okay. Well, this is great. This is still 275. Look at that. This is still 1E99, right? This doesn't change. If you're curious about this, remember we were talking about this, Autumn? You go, what's the mean of X bar? Look, it's just mu. It's the mean of that population. It's just mu, so I'm gonna still put the 266 here. Doesn't this look identical? All the way except now. Now I'm talking about, oh, well, you got a sample size of 20. N equals 20. So I'm going to take this 16, divide the square root of 20. And see what you get. That's all we do. Section 8.1 is not that bad. Ooh, what'd you get?
0.0059.
See how low that is? That was like 1%. Here's the thing. 0.0. For this one, when we're getting an answer of, this was 0.286. I'll just put a line between these. But this answer is coming out to be right here. 0.0059. This would be unusual. Isn't that interesting?
This is kind of like the AND function, right? Like when you multiply a lot.
Exactly. That's exactly it.
Oh.
This would be very unusual. You really just 20 women? Yeah. You get a 20 randomly chosen pregnancies, right? And you take you look at, all right, what's the chances this could happen? 1% chance. Right? It'd be closer to the what? The 266 days. Cool? You want to give this? Hey, try, Autumn was at number 19 from 8.1. Make sure you try that. That's good practice. They do less than. So in less than, your image, here you're doing a negative 1E99 and then you put in a number. Do y'all agree? Because your shaded region's over here. Cool? Is that okay with that? All right, ready for 8.2? All right. I can erase. That one, great job. That's 8.1. That's really what it's all about. It's just we're being very careful with that standard deviation. And everyone, I love when you look for keywords. What's keywords in here? Mean. You would see this. You would spot that, the X bar. You'd be thinking, okay, X bar. Cool. All right, I'll erase. Now, and the last thing we're covering is the distribution of the sample proportion. Now, there's some symbols in there we haven't seen before, so we have to start out and make sure we understand what these are. So, just for comparison, just to compare, we've seen that symbol many times, and we've seen this symbol many times. Can we talk about what these symbols meant, then we'll do 8.2. This is the sample what?
Mean.
That's the sample mean. You know, a sample of like 20. This is the
Population.
population mean. We're talking about millions. Right? Thousands and thousands, population mean. All right. In this section, here's a new symbol. P hat. That's called the sample proportion. So when this was 8.1, well, this is what we got in 8.2. We have a new symbol in here. It's a P with a hat on it, and call it a P hat. Right? Call it P hat. Here, your P hat. It represents the sample proportion. Now, it does has a little formula to it. This is always equal to X over N. I'll give you a quick example. And when there's 100 people in the auditorium over there, and I want to look at the chances that I would get 18 left-handed people out of the 100 people. Okay. Well, this would be 18, and this would be the 100. You go, oh, 18 over 100. Right? Well, here's another one. I've done this before, you know this, but let's do it again. I'm going to include myself. How many lefties in this class? It's never looking at lefties. All right, 1, 2, 3, 4. 4 out of, but for this I have to count up what? All the people in the class. I'll estimate, it's like about 25. Sample proportion. Now, obviously, you can write these as decimals. So when you can do that on a calculator, unless you want to do that in your head, what's that decimal right there?
0.6, no, 1/6 something, right? So,
What base? 16 over 100 is at 0.16?
yeah.
Did y'all get that? So I just want to point out, everyone, a lot of times you're going to be writing these as decimals like this. You could write 16%, but you can write these. You'll get a fraction first, but you'll immediately do what? Write decimals, right? Absolutely, just do that. Just go, all right, what is this? Now, can you be careful of one thing? When you get that repeating decimal that does what? You know this stuff? If it does that, don't just round that to 0.3, you know? Because we don't want to round to the final step. So write it out a few places, like if that came up in the first step, write it out like, here, 3, 3, 3, 3, 3, 3. If E3's in there, we'll be good. All right, that's the sample proportion. This symbol, everyone, is the population proportion. So this is the population proportion. Now, that's for all lefties. And about 16% of this group here is left-handed, but for all lefties in the world, it's closer to about 13%. This number will be given to you in a lot of the problems. Right? Hey, what letter does that look like? From the alphabet.
Uppercase P.
Yeah, it looks like a P, doesn't it? But do you remember we like to use Greek letters for these population parameters? Right? And was like, yeah, that's a P. These are Greek letters. This is really the Greek letter rho. I just want to point that out. Now, there's nothing wrong with you. I have no problem with this. When you do your homework and practice this stuff, if you call it P, because it looks like a what? It looks like a P. So it's okay if you're doing your work, or if in class you call it P. I have no problem with that. We're calling that P hat, because that is P hat. But it's really the Greek letter rho from the Greek alphabet. All right? Because we always use these Greek letters for the population proportion. So I just want to point that out. It's rho, but feel free to call it a P, because the word population starts with a what? P. Population proportion starts with a P. And it looks like a P, but it's the Greek letter rho. All right. So there's the population parameter. These are going to be our samples. We're going to calculate this in the problem. Okay? And we'll do stuff similar. I do want to